Hello, let me take this opportunity to welcome you to this class. So in this class, we are going to discuss a chapter in Form 3 where we are going to discuss the quadratic expression and that is the quadratic expression and equation 2. So I'm going to remind you what you learned in Form 2 while you were there, but that's the method by factorizing the expression, and these were expressions and not equation. Remember the difference between the expression and the equation. Equation will always have the equal sign equating the two sides, but the expression will only have one side. So I can take my highlighter here and then I start with. So in this case, maybe for example, I can have the first one here. Remember, if I have to factorize out this, I need to have the product here, which is positive 9, and the sum, which is equals to maybe 6. I look for two factors that I can add to get 6 and then multiply them to get 9. So I'll have 3 and 3. So here I'll have 6x then plus maybe 3x then plus 3x then plus 9. So remember, I have just replaced the 6 with those two factors. So here I can have x being common, and then here I can have x then plus 3, and then here I can have maybe 3 being common, and then I can have x plus 3. So remember, this equation is divided into two equal parts. So when factorized, that is that, and also the plus x that way, which also can be written as x plus 3 maybe squared, and this one results to a perfect square, which also you can just take the square root of 9 and also the square root of x squared and have the same equation. So the other bit, I'm going to have the product here being 6 here, but here the sum is equals to negative 5, and the two factors about this is what? So I can have x squared here, then minus the two factors here maybe is negative 3x, and then also negative 2x, and then maybe plus 6, like that. So here I'm going to have this one being, what is common here is x, and then here I'll have x minus 3, and then here I have negative 2. So here I will be left with x minus 3 also. So I can have this one being x then minus 2. I take what is outside, and what is inside is x minus 3. So that is how I can factorize out that. So let us have another example. So in this other example here, we can try to have it. So here the product here becomes 16, but the sum here is equals to negative 8. So two factors here that I can add to get negative that becomes negative 1, 4. So we have x maybe squared then minus 4x then minus 4x, and then the other one is a plus 16 here. So here now I'm going to have this one, what is common here, I'll have x, so this is x squared, sorry, x, and then here I'll be left with x then minus 4, and then what is common here is a negative 4. So here I'll be left with x then minus 4 there. So now you'll realize that this also is a perfect square because it is dividing the two factorized sides equally, which is x minus 4, which we have said it can also be written as x then minus 4, and then we square it. So the other one here, we have our products being equivalent to negative 12, and here our sum is equivalent to maybe positive 1. So in this case here I'll have this one being what? I'll have the sum being negative 4 and 3. So I'll have x here squared, then maybe plus 4x, then minus maybe 3x, then minus 12, like that. And then I can factorize out these, so that here I have x, so I'll have be left with x maybe plus 4 here, and then here I have negative 3, so I'll be left with x then plus 4. So I can pick, you can see the one that is inside is the same, so I'll have here being x minus 3, and the other one being x maybe plus 4, like that. So you see, you realize that wherever there is the two factorized sides being equal, that results a perfect square, which you can just take the square root of, maybe for example the first case here is 16, you can have 4, and then we can x squared, we can have x, and then we divide it by, we take the sign, we take that sign, and then we put the equal sign. So the other one here, this is just a conclusion. Remember, we have said that maybe this one being a completing square or a perfect square, realize maybe, for example, if we take x squared then plus 6x then plus 9, you can just take the square root of x, which is x, then the sign that is here, which is a plus, and then the square root of this 9, which is 3, and then you just square. So that is how you can just simplify a perfect square. And what you are going also to realize here is that if you take if this one is our a x squared then plus b x then plus c here, if you take the value of 6, that is 6, then you divide by 2 this one, and then you square it, this one will result to the value of this 9 here, that 9 there. Maybe if you take 6 divided by 2, it is 3 squared is that, meaning that if we have b divided by 2, then we square this one should give us the value of constant, the value of constant c, the value of constant c. So let's go to the next. So in this case, let us apply. What can we make it to be perfect square? Remember, we have said that if you take c and then is equivalent to b divided by 2, then this one squared. So now for us here, we can maybe add the constant c there. So we are going to say that maybe here, so that we can have it being 6 x squared then plus maybe 10 x then plus c. So, and remember, for us to get this c, we have said that this c will be given by the value of b here is 10 divided by 2, then we square this. So of course, if you take 10 divided by 2, you get a 5, then when you square this, you get a 25. So meaning that 25 is the number that is the constant that can be added, that, so that we have x squared then maybe plus maybe 10x then maybe plus maybe 25, that way. So in that case, remember, that becomes a perfect square, The same case, you can have it letting that constant c. So we have maybe x squared then plus maybe 10x maybe then plus c, and then this one you can say maybe is equivalent to, if you get the square root of c here, we can say the square root of x squared is x, and then the square root of c there, we can introduce another constant which you can call it k, and then we square it. And remember, you can expand that. So we have x squared then plus maybe 10x maybe plus c. This one will be given by maybe x squared then plus 2xk and then plus maybe k squared. And then in this case, you can compare the two, where we have this x squared and that x squared. So we shall have maybe 2k is equivalent to 10, and then we can divide by 2, and then we can be left with k is equals to 5. So if k is equals to 5, we know that c is equals to k squared. So meaning that our c will be equivalent to 5 then squared, which is equals to 25. So it is also true to say that this one can be the same as x squared then plus maybe 10x then plus 25 to make it a perfect square. So the next one is the value of that. Remember, in this case here, we can maybe have this one adding bx here. So that is the coefficient that is left there, and we know that for us to get, we know that our b all over 2 maybe squared is equals to c, and this case our c is 36. So it is wait for us to say that b divided by 2 here is equals to, then squared is equals to 36. Then we can get the square root, and also we can get the square root there. so that we have b divided by 2 is equivalent to plus or minus 6, and then we can take this on the other side, so we have b is equals to either plus 12 or minus 12. So it is wise for me to say that I can either have 12x or maybe negative 12x, like that, or negative 12x, like that. So that is one way that you can approach such a question. Also, alternatively, we can have it being the same, that is we have maybe x squared then plus maybe bx, and then plus maybe 36 here, and then this 36 is equivalent to, here we shall have this one being maybe x plus m maybe squared. Remember that is a perfect square, and then we can expand that to get maybe x squared maybe plus bx then plus maybe 36. This should be equivalent to maybe x squared then plus maybe 2xm then plus maybe m squared, which is equivalent to that. So we can take that 6 is equals to m squared, so you can get the square root on the other side, and that, remember, if you get a square root you can get either a positive or minus 6, which is equivalent to m. And remember, here we know that our b is equals to 2m, is equals to 2m, so it is wise for me to say that my b becomes 2, then I multiply it with either a plus or a minus 6, which results to me that my b can either be 12 positive or can be either negative 12. So it is wise for me to say that we can either have 12x or still negative 12, or negative 12x, or negative 12x. So can we proceed? So in this other one here, it is good for us to say that in this case we know that our b all over 2 squared is equivalent to a multiplied by c. That is the coefficient of x squared multiplied by constant c. So in this case, our b divided by 2 squared should be equivalent to 25. Then this 25 we multiply by 9. So in this case, we're going to have b all over 2. Then this one is squared is equals to 225. So we can get the square root on this side and also the square root on this side. So we shall have b divided by 2 is equivalent to plus or minus 15. So if we take this on the other side, so we shall have b equivalent to either positive 30 or negative 30, or negative 30. Although you can also take this one to be a perfect square, which is 25 maybe x squared then plus maybe here we add the bx then plus 9, and then on the other side we can say that if this one is a perfect square, we can get the square root of 25x, which is 5x, and then the square root of 9, which is 3, like that, and then we try to expand it and see what you're going to have. So here we are going to have maybe 25 x squared then plus bx then plus 9. This one should be equal to 25, and maybe x squared then plus, here we shall have this one being what? This one is this. Remember, this one is the same as if we are taking the 5x maybe plus 3, then you multiply it by 5x then plus 3, like that. So meaning that in this, the first one we're going to have the first one, which is 5x multiplied by 5x, which is 25x, and then this one is 5x multiplied by 3, which is 15x, then plus 3 multiplied by 5, which is 15x, and then plus 9. So remember, at the end of the day here we are going to have still 25x maybe squared then plus maybe that x and then plus 9. So you can see our b there in that case is 30, which means you can either take it as a positive or a negative, a positive or a negative. So you can go to the next one. In this other one we have a dash maybe negative 40x plus 25. Remember in this case we have said one thing, that is we have said that if you take if you take b divide by 2 then you square it, it should give you ac. So in this case we don't have a, what we have is c. So it is good for me to say that if I take negative 40 then I divide by 2 then I square that, I'm going to get 25a. So this is what? This is 400 is equivalent to 25a. So I can divide by 25, and also I can divide by 25. Can divide by 25 on both sides. So my a here is equivalent to 16. My a is equivalent to 16. So it is prudent for me to say this is 16x squared. That is also 16x, the 16x squared. 16x squared. Remember also you can do it with the long method, that is where we have maybe this being negative 40, maybe x then plus 25, like that. This one you can say is equals to the square root of that, we can say it is maybe mx, and then plus the square root of 25 is 5 of course, and then you can have it squared there. So remember you can expand that. If you expand this, you can expand this to get maybe, for example, what if you expand this, you get m squared then x squared, m squared then x squared, then plus maybe 10xm, maybe 10mx, and then maybe plus 25, like that, 25 like that. So the next thing is for us to equate the two. So remember here we are now going to have maybe our 10m maybe is equals to negative 40. So in this case our m will be equivalent to negative 4. So meaning that our a is equals to m squared, and then now we can have our a is equals to negative 4 squared. So in this case our a is equals to 16, so we can say this is also equivalent to 16x squared, 16x squared. So that is how you can have to make that. Remember the process of adding that term to make it a perfect square maybe is called a completing square method. So we can proceed to do this using the completing square method. Remember the difference between the two is that, for example, in this, let us do it in this, what you just need to do, remember we have done when the coefficient of x was 1, so you need to make the coefficient of x to be 1 in this case. So you divide by 2 all through, so we shall be left with, if you divide by 2 we shall be left with x squared then plus 2x then plus maybe half is equals to 0, maybe plus half is equals to 0, and then from there now we can be able to maybe subtract the half on both sides. So we shall have maybe x squared then plus 2x then is equals to negative half, like that. And then the next thing is for us to introduce the constant c. So here we shall have maybe x squared then plus maybe 2x and then plus maybe 2 divided by 2, then we square. Remember our c is equals to b all over 2 squared, and then is equals to, this is 1 then minus half. Remember 2 divided by 2 is 1, and then square is just 1. So at the end of the day, if we factorize out here, we are going to be left with x plus 1 squared maybe is equals to half. Then we can get the square root on this side and also the square root on the other side, so here it is wise for me to say, maybe for example here now I'll be left with x maybe is equals to negative